A pendulum bob of mass m on a cord of length L is pulled sideways until the cord makes an angle theta with the vertical, as shown in the figure. We want to know what is the change in potential energy of the bob during the displacement. So first, before we start labeling things, let's go to our potential energy equation. EP equals mass times g times height. Now we want to know what is the change in potential energy. In other words, what is the difference in potential energy from here to here? So what we can do is we can just assume that the potential energy at the lowest point is equal to 0. And then we can just find the potential energy at the highest point, and that is our answer. Now, to know what that potential energy is, we need to know the mass. Well, we're told it's just got a mass m, so we have that. But we also need to know its height, at least relative to the lowest position of the bob. So the height is going to be this distance here. So we have our potential energy equation. We need to find height, and then we've solved it. So looking at the bigger diagram that I've drawn here, the height is represented by the difference in height between the highest and lowest points, which would be this length here. Okay. Now we can draw some more things to make our diagram a little bit clearer. Little right angle triangle, you might draw that so we can clearly see the height in relation to some other angles. Now what we want to do is, if I draw a line perpendicular from the height, in other words, coming straight out to the right from our bob at the height h, we reach this point here on the rope. And now what I want to focus on is this triangle that I'm going to highlight here in green. Okay. This triangle is a right angle triangle. And what we can do is, if we can find the length of this length here, if we can find this length, which we'll call L primed, and because we know the length L, which is the full length of the rope here, then we could take L, subtract from it L primed, and that would give us the height h. So we just need to use a little bit of trig to figure that out. Now looking at the right angle triangle in green, we can say that cos of the angle using SOHCAHTOA is equal to adjacent divided by the hypotenuse. So in our case, the adjacent is the pink L primed, and the hypotenuse is the length L. And if we just solve for the length L primed, we get L cos theta. Now to find the height h, as you can see, maybe I'll draw a little comparison on the side here. So we have the full length L of our rope, that's L, and then we have the shorter length L primed that we just found, and then there's also the height h, which is this length right here. If we take L and subtract from it L primed, we'll get the length h. So let's do that. L minus L primed is equal to h. Okay, well, we know what L primed is. We just solved it over here. So L minus L cos theta. And if we want, we can factor out the common factor of L, giving us 1 minus cos theta multiplied by L. And that's our height. Okay, now we can take this height and substitute it into our potential energy equation. So potential energy is equal to mg times the height, which is L, multiplied by 1 minus cos theta. And that is the potential energy.